This is section 2.5. This is practice B. Numbers 1 and 2 are simple algebraic proofs. You fill in the blanks for the reasons. You can pause the video if you need to take a look at those. The tougher ones would be number 3 through 5. These are more geometric proofs where you have to rely on looking at a diagram and some of the postulates and definitions that we need to use and properties on our theorem packet. Okay, so we're going to take a look at number 3. They're telling you the distance from A to B is equal to the distance from B to C. That's given. And you know that that's true even if it wasn't given to you there. Notice how the marks are the same in the picture for those segments. Okay, that actually means the segments are congruent, but we're saying their lengths are equal right now. How do you know the distance from A to C equals the distance from A to B plus the distance from B to C? You have two little segments that add together to give you the big one. What's that called? That's your segment addition postulate. Little plus little equals big. You need to look at this and read it, understand what it means, and then be able to find it over here as two little segments in a big segment. Okay, so if you didn't get that the first time through, I think the next time you get it, it'll be a little more comfortable, and then a couple times after that, you're going to start recognizing it on your own. But you have to do your part. You have to read this, and you have to try. Otherwise, you're really going to be confused because this is the direction that we're going. Next line down. Distance from A to C is equal to the distance from A to B plus the distance from A to B. We know this statement is true, and we know this statement is true. So if we kind of use those together, we can say this. Because B to C, isn't that the same thing as A to B? That's what it told us up here. So if they're the same, can't you take this one out and put that one in? That's substitution. So now we know that the distance from A to C is really just the distance from A to B plus the distance from A to B. And we can kind of clean that up over there. There's two of these distances from A to B. So really you just combine the like terms there or simplify. It's up to you how you want to write it. Number 4. There's a bunch of angles here. Okay, 6 different angles. They're telling you the measure of angle AEB, that's this little skinny guy here, is equal to the measure of angle CED. That's given. If they didn't give that to you, you would know because of the marks. How do you know that the measure of angle BEC equals the measure of angle BEC? Any angle is the same as itself. That's your reflexive property. This next statement is going to follow from the last two things that we just talked about. Measure of angle AEB plus the measure of angle BEC equals the measure of angle CED plus the measure of angle BEC. It's probably going to look really, really confusing to a lot of us. All they're doing is taking this first statement where you have two angles that are equal, and you're adding the same thing to both sides. Measure of angle AEB, measure of angle AEB. Measure of angle CED, measure of angle CED. Notice how this guy, it's the same as itself and it's added to both sides. I know it's kind of disguised, but it's no different than adding something to both sides like we did up here. It's the same concept, except now it's using geometry instead of what you're more comfortable with, which would be algebra. That's the addition property of equality. You're adding the same thing to both sides. Doesn't matter if it's an angle or a number. Measure of angle AEC is equal to the measure of angle AEB plus the measure of angle BEC. You're going to need to look at the diagram for this one. Angle AEC is this big angle, and it's a combination of angle AEB and angle BEC, the two little ones. Two little angles make a big angle. Remember how two little segments made a big segment up here? It's the same thing. That was segment addition postulate. This one is angle addition postulate. Measure of angle BED, that's this big angle, is the same thing as the measure of angle CED plus the measure of angle BEC. These are the two little angles. These two little ones make this big one. It's the same thing. Angle addition postulate. If we were on our own and we were being creative, you could have combined both of these things in the same statement because the reason is the same. That might look a little cluttered. That's probably why they have it separated. How do we know the measure of angle AEC equals the measure of angle BED then? Well, if you look around here, I'm going to try to use some colors here to hopefully help you. I'm going to make that guy blue. Notice how it's the same thing as that guy. It's the same exact thing. So if this guy equals this blue thing, and this blue thing also equals this other thing, I guess I could make that something different. Maybe I'll make it yellow. See how the yellow thing is equal to the blue thing. And then we say this blue thing equals another angle, and this yellow thing equals another angle. Well, if the yellow and the blue were the same, and the yellow and the blue each equal something different, wouldn't those two things be the same as each other? That's your transitive property. You have two different things that are basically equaling the same thing. So they have to be the same as each other. Number 5. Two lines are perpendicular. That's what that means. Another two lines are perpendicular. So they don't show that in the picture. You could actually put that in there though. If two lines are perpendicular, this is the marks that you'll see in the diagram a lot of times. Now, what does that mean if two lines are perpendicular? That's going to mean that these angles here, where the lines cross, are going to be 90. And that's what they tell you. So you know that by definition of perpendicular. Perpendicular means you get right angles there, or 90-degree angles, I should say. Well, look here how two different angles end up equaling the same thing. If you have two different things, blue and yellow, equaling the same thing, the pink, then those two things that you thought were different because you made them different colors, they're really the same. That's your transitive property. If I'm as tall as Bob, and Bob is as tall as Charlie, then me and Charlie are the same height as well.